Okay, we are starting on the last chapter here, chapter 12, and chapter 12 deals with different types of sequences and series. So here in 12.1, we are going to look at an introduction to sequences and summation notation. Sequences and summation notation. Okay, so instead of starting off with a formal definition of what a sequence is, let's go ahead and take a look at some examples of sequences. Then we'll talk about the formal definition of what a sequence is. Okay, so sequence examples. And then that way the definition will probably make a little more sense. Okay, so this here, 5, 10, 15, 20, 25. This here is a sequence of numbers. So is this one here, 2, 4, 6, 8, 10. And they should be familiar to you. Okay. Some sequences might be familiar to you, some may not. If I write down this one, 1, 4, 7, 10, 13, 16. You might be staring at this and going, oh, I don't really recognize that or what the pattern is. But if you stare at it a little bit longer, you might be able to figure it out. Same thing with this next one. 1, 4, 9, 16. And if I keep going, if you don't see it right now, I think you'll see it eventually. 25, 36, 49, 64. Okay, so some of you probably have noticed the pattern there. Anyway, so these are examples of sequences. So you should be able to see that, okay, well, these are a list of numbers and there's some sort of a pattern here in each one of these. Okay, so let's take a look at the formal definition of what a sequence is. Okay, so a sequence is a function whose domain is a set of natural numbers. So not the real numbers, natural numbers. Do you remember which ones are the natural numbers? Those are 1, 2, 3, 4, 5, 6. Okay, so sort of like one way to remember it, it's sort of like the numbers you naturally started with. Okay, maybe some of you guys started with 0. Okay. Okay, so anyway, the domain of the sequence is a set of natural numbers, 1, 2, 3, 4, 5, 6, etc. And the terms of the sequence are f of 1, f of 2, f of 3. So you plug in 1 to find out what your first term is. You plug in 2 to find out what your second term is. You plug in 3 to find out what your third term is, etc. Okay? All right. And this keeps going. Okay, so but we don't really use the function notation here. So what we do is, so if we look at these, we see we have a list of numbers, right? So like in this first set of numbers over here, okay, so the first term is 5, second term 10, third term 15, fourth term 20. Same thing here, first term 2, second term 4, third term 6, fourth term 8, etc. And then the same goes for these here. Okay, so we have a list of terms. So instead of using this notation here, function notation, we use this notation. So yeah, we would plug in 1 to figure out what that first term is. But then we call that first term A1. Okay, and yes, while we plug in 2 to figure out the second term, we represent the second term using A2. And then the same thing with the third term. Yes, we plug in 3, figure it out, and we represent it with A3. We plug in 4, and we represent the fourth term with A4, and we do that for all the terms. Okay. So here, A1 is the first term. A2 is the second term. A3 is the third term. Okay. And we keep on going. And whatever that n number is, it will be the nth term. Okay. And we can use the function to define the sequence. Okay, so for example, that first one that we looked at, 5, 10, 15, 20, 25, and it goes on and on. Well, that's your first term, right? And that's your second term, that's your third term, that's your fourth term, that's your fifth term. And so what happens here is we try to look for a relationship between that first term, 5, and the number 1. We try to look for a relationship 10 and this number 2, 15 and 3, 20 and 4, 25 and 5. Okay, so hopefully you see the pattern. Okay, so maybe you can figure out what the function is. The function is if this number is plugged in, right? If when I plug in these numbers, when I plug in 1, I get 5. When I plug in 2, I get 10. When I plug in 3, I get 15. When I plug in 4, I get 20. When I plug in 5, I get 25. So hopefully you know what the function is. It's 5 times n, right? Okay. But instead of using function notation, instead of saying f of n, so instead of using this, so we don't use that. So we're going to use this instead. Okay. So that nth term is basically the function. Okay. All right, so let's take a look at finding the terms of a sequence. Okay, so we're going to take a look at these examples here. And for all of these examples, we're going to find the first 5 terms. Find the first 5 terms. And we're also going to find the 100th term. And the 100th term of the sequences defined below. Okay, so we'll do a few of these. Okay, so let's do this first one. Suppose that my function is 2n minus 1. Okay, so this is the function you'll be using to find the first term, the second term, the third term, the fourth term, and the fifth term. And then after we find those 5, then we will look for the 100th term as well. Okay. Okay, so that's our sequence function. So to find the first term, we're going to plug in 1 for n and work this out. Okay, so our first term is 1. Okay, let's find our second term. To find the second term, a2, we're going to go ahead and plug in 2 into our function and work this out. And we get 3. Okay, and let's find, so our second term, a2, is 3. Let's find our third term. Remember, they're asking us here to find the first 5 terms. So far, we found the first 2. Okay, so a3, our third term, we're going to plug in 3. So we get 6 minus 1, and we get 5. Okay, let's find the fourth term, a4. So let's plug in 4. And we get 7. Okay, and we're almost done. We need the fifth term. So 2 times 5 minus 1, 10 minus 1 is 9. Okay, so we found the first 5 terms. They are 1, 3, 5, 7, and 9. But we also need to find the 100th term. So if I plug in 100, then I get 199. Okay, so my first 5 terms, are 1, 3, 5, 7, 9. Okay, and the 100th term is 199. Okay, all right, let's take a look at another one. Okay, the one I had planned is a little boring, so I'm going to do a different one. So let's take a look at this one. An equals -1 to the nth power, 2 to the nth power. Okay, so this is your sequence function. So this is what you use to find your first 5 terms and the 100th term. Okay, all right, so let's go ahead and find the first term, a1. So we plug in 1 for n, and we have 2 places for n. Here, we're going to plug in 1, and here, we're going to plug in 1. Okay, so we're going to get -1 to the first power, 2 to the first power. Okay, so -1 to the first power is -1, and then we get 2. Okay, let's find the second term, a2. So now, over here, for n, I'm going to plug in 2. Okay, both places. -1 to the second power, 2 to the second power. Okay, and let's go ahead and work those out. -1 squared is positive, and 2 squared is 4. Okay, a3, same thing. I'm going to plug in 3 for n. So -1 to the third power is -1. 2 to the third power is 8. And then for a4, our fourth term, we're going to plug in -1. We're going to plug in 4. Work that out. Negative 1 to the 4th power is positive, and 2 to the 4th is 16. Okay, almost done with the first 5 terms. A5, we're going to plug in 5 for n, so negative 1 to the 5th and 2 to the 5th. Okay, so negative 1 to the 5th is negative 1. 2 to the 5th is 32. Okay, so we found the first 5 terms, and now we are going to find the 100th term. So we're going to plug in 100 for n. So negative 1 to the 100th power is positive, and I don't have a calculator with me, so I'll leave that as 2 to the 100th power. Okay, so the first 5 terms. First 5 terms are negative 1/2, positive 1/4, negative 1/8, positive 1/16, negative 1/32. And our 100th term is 1/2 to the 100th power. Okay. Okay, so that's all pretty straightforward. When you're given the sequences function, it's pretty straightforward. Whatever term you want to find, you just plug in that number. So if you want to find the 50th term, then you would plug in 50. Okay, so finding terms when you're given the function, pretty straightforward. Okay, but some interesting things to notice here. Okay, so like this one here, the first 5 terms, all positive, right? But over here, they kind of alternate. One's negative, one's positive, one's negative, positive, and then negative, positive, negative, positive. So whenever you see a sequence like that, because what's going to happen is you're going to have to try to figure out what the function is. They're not going to give it to you. They'll give you maybe the first 5 terms, and you have to kind of guess, determine what the given function is. Okay, so just kind of keep in mind that when you see this alternating signs, there's a good possibility that you have negative 1 to the n. Okay, it might be negative 1 to the n plus 1. Okay, depending on when the negative falls, if it starts off negative or if it goes positive, then negative, positive, negative, positive, negative. Okay, so you just have to kind of pay attention to that. Okay, but when it's alternating, you will probably have that negative 1 to some power. Okay. Okay, so let's take a look at finding the nth term, or finding the function. Okay, so finding the nth term. Okay, so what you're doing here when you see that is you're basically looking for the sequences function. Okay, so whenever you see find the nth term, they're saying find the formula, find the function. Okay, so let's take a look. And so what's going to happen is they're going to give you a list of the terms, and so you have to kind of investigate. All right, so let's take a look here. So before we get into those, actually, let's take a look at this one. Okay, find the nth term. Of each sequence below. Okay, so let's take a look at a couple. All right, let's take a look at this one, since I just went over the whole alternating negative and positive. So suppose you have this, negative 2, positive 4, negative 8, positive 16, negative 32. Okay, so let's have a look here. All right, so we know that they alternate. Okay, we know this is our first term. This is our second, third, fourth, and our fifth. So it's kind of nice to do this. That way you can see, okay, when I plug in 1, I get -2. When I plug in 2, I get 4. When I plug in 3, I get -8. When I plug in 4, I get 16. When I plug in 5, I get 32. Hopefully you notice that these here, 2, 4, 8, 16, 32, those are all powers of 2. So hopefully you notice that. That's like 2 to the first. That's 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Okay, so we at least know that part, right? So we at least know it's 2 to the nth. Okay, but we need it to alternate signs, so we're probably going to have that -1. Okay, so alternating. Okay, so if I have -1 to the nth, so here, when I plug in 1, do I get negative? Yes. When I plug in 2, do I get positive? Yes. When I plug in 3, do I get negative? Yes. When I plug in 4, do I get positive? Yes. And when I plug in 5, do I get negative? Yes. Okay, so this here gives us the sequence. Okay, so our function, or our nth term, is going to be, you can write it like that, 2 to the nth times -1 to the nth. But since they're both to the nth power, you can actually put them inside together and say to the nth power. Okay. Okay. Let's have a look at another one. Let's take a look at this. 1/2, 3/4, 5/6, 7/8. 1/2, 3/4, 5/6, 7/8. So maybe you see a pattern here. What you might want to do here is, when you have fractions, sometimes it might help to look at the numerators separately from the denominators and try to find out the function that way. Okay, so again, that's your A1, that's your A2, A3, and A4. All right, so let's start with the denominators. The denominators look a little bit easier. Okay, because when you plug in 1, you get 2. When you plug in 2, you get 4. When you plug in 3, you get 6. And when you plug in 4, you get 8. So hopefully you see here for the denominator, it looks like it's 2 times n, right? When I plug in 1, I get 2. When I plug in 1 to here, right? When I plug 2 in here, I get 4. When I plug in 3, I get 6. When I plug in 4, I get 8. Okay, so that's how we get the denominator. Now let's take a look and see how we get the numerator. Okay, so we get 1, we get 3, we get 5, and we get 7. Okay, so for some people, they can spot the pattern really quickly. For some, some people, they can find it just pops out to them. And for some people, it takes a bit. Okay, so don't feel bad if it takes you a while to see the pattern. Sometimes certain ones you'll get right away, and other people it'll take them a long time. And the one that takes forever for you to see, other people get really quick. So it just depends on how you're seeing things. And sometimes, just move on to the next problem and come back to it with fresh eyes, and It'll probably come to you, okay? But again, you want to see how it relates to when you plug in 1, you get 1. When you plug in 2, you get 3. When you plug in 3, you get 5. When you plug in 4, you get 7. You might also notice that, okay, look for patterns. Look for all kinds of patterns. Another pattern that we see here is that, okay, well, the numerator is 1 less than the denominator. Well, there you go. If you can find a relationship between them, well, you already know the denominator is 2n. So if you can find a relationship between the numerator and the denominator, then go ahead and use it. So we see that the numerator is 1 less than the denominator. So the way you write that is you say 2n, that's your denominator, but then it's 1 less. So 2n minus 1, okay? Okay. So we have that. There's different ways to come about it, okay? So some people may have seen it like that. They may have seen this relationship between the numerator and the denominator and said, oh, it's 1 less, okay? So maybe somebody saw this and they said, oh, well, let's see. This looks like the sum of, like, when I plug in 2, right? So when I plug in 2 and add the number before it, okay? Some people might look at it like that. Oh, I plug in 2 and add 1. Oh, I plug in 3 and add 1. Oh, I plug in 4 and add not 1, the one before it. Okay, so let's look at that again. Sorry. So I plug in 2, okay, and I add the number before it, 1. I plug in 3, and I add the number 2 before it, right? And then here, I add 4 and 3. Here, I'll probably add 5 and 4. And the next one, right? So another way to represent this, right? These are your n numbers, right? These are the n's that you're plugging in for, right? You would plug 3 in for n. You would plug 4 in for n, right? Okay, so over here, if this is my nth term, right? This is my nth term, then what I would be doing is I would be plugging in, right? We already know the bottom. Bottom's 2n, right? Okay. But for the numerator, I would be doing n plus the one before it, right? N minus 1, right? Just like here, 7, well, I'm doing 4 plus 3. 5, well, I'm doing 3 plus 2, right? For my second term, I'm doing 2 plus 1, okay? So here, let's just do the fifth term so you can kind of see it. So the fifth term, okay, so I would be doing 5 plus 4 on the top. 5, because it's the fifth term, plus the number before 5, which is 4, okay? And then, of course, 2 times n, which is 10, okay? So here, to represent this 5 plus the number before it, 5 plus 4, the way we do that, okay, so if we're doing 5 plus the number before it, right? So if this one is n, then this one is n minus 1. Okay, so there's going to be a lot of this going on as well. You know, oh, how do you represent things before it? Well, so you have to take a look. What does n represent? Okay, and what are you trying to do here? Okay, so try to look for those relationships as well. Okay, so if you saw that relationship, then you would have written n plus n minus 1, right, over 2n, okay? But you'll see if you work this top numerator out, removing the parentheses, you have this, and you'll notice that you get exactly the same thing as you do here, okay? So if you end up doing this and WebAssign doesn't accept it, then just simplify it, okay? Most of the time you're supposed to simplify it anyway, okay? All right, let's take a look at another one. Okay, let's look at this sequence. 2, 6, 12, 20, 30, 42. Let's see if we can guess what the sequence function is. Okay, so this is A1. When you plug in 1, you get 2. When you plug in 2, you get 6. When you plug in 3, you get 12. When you plug in 4, you get 20. When you plug in 5, you get 30. And when you plug in 6, you get 42. Okay, so it might not be clear for the first few, but by here, you should be able to see some sort of a pattern. Okay, maybe not so clear here. 2, 6, 12 starts to look a little, something should start to develop around here. But then once you get to here, 20. Plug in 4, you get 20. Plug in 5, you get 30. Plug in 6, you get 42. These numbers should be standing out to you. Okay, so here, when you plug in 6, you get 42. When you plug in 5, you get 30. Okay, so does that stand out to you? Okay, so here I'm going to kind of do some work here underneath. Okay, so when you plug in 6, you get 42. So you might be thinking, oh, 6 times 7. When you plug in 5, you get 30. Oh, 5 times 6, right? When you plug in 4, you get 20. 4 times 5. So that looks like that is the pattern. So the question then becomes, how do you represent this, right? Okay, so we already know that this first number is n, right? So it's going to be n times something, because these all match, right? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay, so we already know it's going to be n times something. Okay, so the question is, how do we represent that second part? Okay, well, if this is n, how can I represent this in terms of n? Okay, so, well, if I look at that compared to n, look at that compared to n, look at that compared to n, and look at that compared to n, you should notice a pattern. These numbers are all 1 more than n, okay? N being the first number. So 1 more would be represented like that, okay? So, so your function can be represented like this, okay? Again, if WebAssign doesn't accept that, then multiply this out and write it like this, okay? Okay? All right. Okay, so let's take a look at recursive sequences. Okay, so these are our special kind of sequences. These are sequences that do not have simple defining formulas, like the ones that we were just doing. They all have a formula, a nice sequence formula, a nice sequence function, so that we can just plug in and calculate whatever term we want, right? So recursive sequences don't quite work that nicely, but they are still pretty simple. So what happens is the nth term may depend on some or all the preceding terms. Okay, so some or all the preceding terms. Okay, so which means that coming up with just the formula isn't quite possible. Okay, so let's take a look here. So for a recursive formula, if they say, oh, okay, list the first 5 terms, and suppose they give you this, and they tell you that, okay, your function or your nth term, your function is going to be this here formula, 3 times a n minus 1 plus 2. Okay, so this here, what this is saying, okay, if you want to find whatever term here, well, you're going to have to do 3 times the term before this one plus 2. Okay, so it's like, okay, well, if I have this formula and I don't have any terms, I don't know what the term before this one is because I'm trying to figure out this one and I don't know any other terms, right? Okay, so this is a recursive formula where your formula is dependent on knowing the term that's before it. Okay, so here, if I need to list the first 5 terms, they got to give me more than just the formula. Okay, so they might give you something like this, a1 equals 1. Okay, and that's pretty much all you need, and you'll be able to find the first 5 terms. Okay, so a1, your first term, is 1. Okay, a2, according to the formula, is going to be 3 times parentheses. Okay, the term before it, right? This is n minus 1, which means the term before this one. N plus 1 would be the term after this one. Okay, so a2 is 3 times the term before this one, which is 1. Okay, and then we can work this out. 3 times 3. Come on, there it is. Okay, and we get 9. Okay, let's go ahead and find a3. So according to the formula, it's 3 parentheses, and it's going to be the term before the third term, which is the second term. Okay, 9 plus 2. Okay, so this is going to be 3 times 11, which will be 33. Okay, and my fourth term will be 3 times the term before the fourth term, which is the third term, which is 33, plus 2. So 3 times 35, and that will be 105. And then my fifth term is going to be 3 times the term before the fifth term, which is the fourth term, 105, plus 2. And that will be 3 times 107, which is 321. Okay. So my first 5 terms here, first 5 terms are, the first term is 1, second term 9, third term 33, 105, 321. Okay, those are the first 5 terms. Okay, there's also another sequence that's a very famous one. So this one is, it's a recursive sequence. And this one is called the Fibonacci sequence. Okay, so we are going to find the first 11 terms. Okay. And here is your formula. Since this is a special one, it's the Fibonacci sequence, I'll use F and instead of A. Okay, F for Fibonacci. All right, so Fn, here's your formula. It's going to be to find whatever term you want. You're going to take the one before it, so n minus 1, plus the one before that one. Okay, so 2 before the actual. Okay, so you're going to find the sum of the 2 terms before it. That's basically what this is saying, right? Because you're here, like, say this is the 5th term, then this means the 4th term, and this means the 3rd term. Okay, so 5th term, 4th, and 3rd. So you're basically doing whatever term you're trying to find, you're going to add the 2 before it. So if you're finding the 10th term, you'll add the 2 before it, the 9th and the 8th. Okay, if you're finding the 50th term, let's see the 55th term. If you're finding the 55th term, then you'll add the 54th and the 53rd. Okay. Okay, so here we need to know some things for the Fibonacci sequence. I need to give you the first term. Okay, it is a recursive sequence, so I need to give you some terms. I'm going to give you the first term, but I'm also here, it's going to require that you know at least 2 of them. Okay, so I'll give you the second one. So the second one is 1. Okay. All right, so let's find the first 11 terms. Okay, so we know F1 is 1, F2 is 1, F3, add the 2 terms before it. Okay, so 1 plus 1 is 2. Okay, F4, okay, F4, add the 2 terms before it, so 2 plus 1, and that will be 3. Okay, F5, add the 2 terms before it, so that's going to be 3 plus 2. Okay, and that's going to give us 5. F6, add the 2 terms before it, so that's 5 and 3. Okay, let me scroll up. Okay, and then F7, we're going to add the 2 terms before it, so 8 plus 5, that's 13. F8, add the 2 terms before 8, the 8th term, so 13 and 8. Okay, so that's 21. And then F9, so we're going to do 21 plus 13, so that's 34. And F10, add the 2 before it, so 34 and 21. 34 plus 21, and we get 55. And for F11, we get 55 plus 34, and that is 89. Okay, so this is a really neat, really interesting sequence of numbers, and they find the sequence, or not the full sequence, of course, but parts of the sequence appearing in nature. So I'm going to include a little video there about the Fibonacci sequence if you want to have a look at it, just to go, ooh, that's pretty cool. Okay, anyway, okay, so that's also a recursive sequence here. Again, a recursive sequence, it's when you're given a formula, but you can't use it unless you are given 1, 2, or however many terms it takes so that you're able to use the formula. Okay? All right, so let's take a look at partial sums. Okay, so what do I mean by that? Okay, so let's take a look at this sequence first. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, kind of a boring sequence, right? Okay, so, but a sequence nonetheless, right? My AN formula would be N. Okay, pretty boring. Okay, so what we're doing here now is we're looking at sums. So here I have a list of my terms in a particular sequence, right? So so we use this here to represent the sum of the first term. Also kind of boring because you only have one term, so it's going to be 1. Okay. We use S2 to represent the sum of the first 2 terms. So that would be 1 plus 2, the first 2 terms. Okay. And that equals 3. Okay. S3 is used to represent the sum of the first 3 terms. So that would be, in this case, 1 plus 2 plus 3. And that would equal 6. Okay. And S4 would be the sum of the first 4 terms, 1 plus 2 plus 3 plus 4. And this sum would equal 10. Okay. And so on and so forth. Okay. So we use this S with a little subscript to represent the sum. Okay. So we could keep going. So this here, S sub n, would represent the sum of the first n terms. Okay. So if that were 100, then S100 is the sum of the first 100 terms. Okay. All right. So let's have a look. Find the first 4 partial sums and the nth partial sum of the sequence given by a sub n equals 1 over 2 to the nth. Okay. All right. So since we want the first 4 partial sums, that means we're trying to find the sum of the first term, sum of the first 2 terms, sum of the first 3 terms, and the sum of the first 4 terms. So we're trying to find S1, S2, S3, and S4. Okay. So we first need to know what the first 4 terms are. We don't need the 5th one. because we're only doing the first 4 partial sums. Okay, so let's go ahead and list the first 4 terms. First 4 terms. Okay, so to get the first 4 terms, okay, so to get the first term, let's plug in 1 for n, and we get 1 over 2. Plug in, to get the second term, plug in 2 for n, and we get 1 over 4. To get the third term, we'll plug in 3 for n right here, and we get 1 over 8. And for the fourth term, we'll plug in 4 for n, and we get 1 over 16. Okay, so we have our first 4 terms. So now we just have to find the first 4 sums. Find the sum of just the first term. That one's easy. That's just 1/2. We'll find S2, which is the sum of the first 2 terms, 1/2 and 1/4. Okay, we need common denominator here. So common denominator is 4. So we get 2 over 4 plus 1 over 4 equals 3 over 4. Okay, so S2 is 3/4. S3, the sum of the first 3 terms, so that's 1/2 plus 1/4 plus 1/8. Okay, so 1/2 plus 1/4 plus 1/8. And the common denominator here is 8. So 4 over 8 plus 2 over 8 plus 1 over 8. That's 7 over 8. Okay. And S4, that's the sum of the 4 terms. So 1/2 plus 1/4 plus 1/8 plus 1/16. Different ways to go about this. Okay, so, all right. Common denominator, or, okay, so instead of doing these 4, I already know the first 3 equals 7 over 8. So this is like to saying, oh, well, that's 7 over 8 plus 1 over 16, right? So then LCD is 16. So that's 14 over 16 plus 1 over 16. So that's 15 over 16. So you can do it that way too. Okay. However you want. Use a calculator. Doesn't matter. Okay. All right, so we found the first 4 partial sums, but look at here. It also said, okay, so find the first 4 partial sums. Did that. And the nth partial sum. Okay, so here we go. So what's happening here is, okay, well, when we find this sum, we get an answer. We get an answer, we get an answer, and we get an answer, right? So we essentially have generated another sequence. 1/2, 3/4, 7/8, 15 over 16. Okay, so here they want to know what the formula would be for the sums. Okay, so we're going to try to find that formula. Okay, so this is like S1, this is S2, this is S3, and S4. So when we plug in 1, we get 1/2. When we plug in 2, we get 3/4, etc. Okay, but again, you might want to try to look at the numerators and the denominators separately. Okay, so again, it looks like it's easier to see the denominator here. When I plug in 1, I get 2. When I plug in 2, I get 4. When I plug in 3, I get 8. When I plug in 4, I get 16. Again, powers of 2. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. Okay, so we know it's 2 to the nth. Okay, what about these top numbers? 1, 3, 7, 15. Okay, 1, 3, 7, 15. Any relationship to the denominator? 1, 3, 7, 15. Okay, I think I see it. Okay, so if you don't quite see a relationship going from 1 to 3 to 7 to 15, see if you can find one that relates to the denominator. Okay, 1, you get 1 and 2, 3 and 4, 7 and 8, 15 and 16. So hopefully you're seeing that, oh, the numerator is 1 less than the denominator, right? Do you see that? Okay, it's 1 less than the denominator. So here's your denominator, but it's 1 less. We've seen this before. Okay, so this would be our function for the summation sequence. So this is how you find the Sn, the nth partial sum. Okay, so this is nice to have because we see here at the top, I'm trying to scroll, but it's slowing down. Okay, there. Okay, so we see here when we're trying to find just the sum of the first 4 terms, I had to find the first term, the second term, and the third term, right? I had to list them so that I can find its sum, right? Well, what if I am asked to find the sum of the first 50 terms? I don't want to have to list all 50 terms, right? And because I have this formula for my sequence of my summation answers, right? I now have a formula, so I don't have to list the first 50 terms. I can just plug in 50 over here, and I can come up with the answer for the sum of the first 50 terms. So that's what they're trying to get you to do here. Yeah, find the first 4 partial sums, okay? And we do that, and that generates a whole new sequence, 1/2, 3, 4, 7, 8, 5, 15, 16, a sequence made up of the sums, right? But if you can find a formula for that sequence of sums, then you're kind of golden because you don't have to write all 50 numbers down and then add them all up to find the sum of the first 50 terms, let alone the first 100 terms. Okay. All right. Let's see. Let's talk about sigma notation so that all these sums, we don't have to write so much. Okay. So let's take a look at sigma notation. Okay, so sigma notation, that's when you use this Greek letter. Okay. All right. So let's take a look. We know what a sequence looks like, right? So we have A1, we have A2, we have A3, A4, right? And then we know what we have to do when we're trying to find partial sums, right? When we're trying to find the partial sum, and maybe we're adding A1 plus A2 plus A3 plus A4, right? Okay. And so what happens is with sigma notation, it kind of allows us to do less writing. So sigma notation. Okay, so instead of spelling it all out, oh, find the sum of the first 12 terms. Instead of saying all of that out loud or spelling that all out, we could use this notation. Okay, this says find the sum. Okay, so that's a lot of words in one symbol. So that says find the sum. And so, and it'll say starting from what term. Okay. And so this down below, that part, k equals 1, that tells us starting from what term. So that's telling us start with the first term and go all the way up to the nth term. Okay. So that's what just this little bit here is saying. Okay. So this is saying find the sum from the first term all the way up to the nth term. Okay, so if there's a 7 up here, they're saying find the sum of the first 7 terms. If there's a 50 up here, they're saying find the sum of the first term all the way up to the 50th term. Okay, if there's a 100 up here, this would be saying find the sum of the first term all the way up to the 100th term. But it doesn't always say 1. Maybe it says start at the 50th term. Okay, so maybe it says 50. Okay, and maybe up here it says 100. Then that would be saying find the sum starting from the 50th term. So this is where it starts. This tells us where to start. This tells us to start from the 50th term and go all the way up to, you'll see a number here. So something like this, 100. It's coming. There it is. Okay, so when you see something like this is saying find the sum starting with the 50th term all the way up to the 100th term. Okay. All right. So, and then you have this. And that's where your function would go. Okay. So here I'm going to erase this and this, keep it a little more general. But they're not erasing. That means my lecture has gone too long. Okay. All right. So 1 to n. Okay. But imagine a number up here, this upper limit. Okay. And this is just your function so that you know how to find every single one of those terms. So to find the first term, you would plug in 1 into this formula. To find the second term, you would plug into this formula. To find the third term, you would plug in 3 into the formula that's here. To find the fourth term, you would plug in 4 into the formula that's sitting here. Okay? When do you stop? When you get to the number that's up here. So if it says 50, you got to do it for 50 times, right? You won't get anything like that. Don't worry. You will, but there's going to be a shortcut to finding the answer. Okay. All right. So this here, this means you will be adding starting from the first term all the way up to the nth term. We don't know what that n is. It could be anything. Okay. It could be 50. It could be 100. It could be 3. Okay. All right, let's try some. Find each sum. Okay, so we'll do a few. All right, let's take a look here. So suppose it says this. Okay, find the sum. And let's start with the first term. So k equals 1. So we start from the first term, and let's go all the way up to the 5th term. That's not too bad. Okay, so we're going to start from the first term, and we're going to go all the way up to the 5th term, and we're going to add them all up. Okay, and here's your function to find each of the terms. Okay. All right, so let's find the first term. To find the first term, remember we have to find the first term all the way up to the 5th term. First term, second term, third term, fourth term, 5th term, and then add them all up. And to find them, we use this as our function. Okay, so I'm going to, for the first term, I'm going to plug 1 in to here. So 1 squared. To find the second term, I'm going to plug 2 in right there. To find the third term, I'm going to plug 3 in right there. To find the fourth term, I'm going to plug 4 in right here. And then to find the fifth term, I'm going to plug in 5. And I only have to go up to the fifth term because it says so right here. Okay, this is like your lower limit. Where do you begin? This is your upper limit. Where do you stop? Okay. Okay. Work that all out and you get 55. Okay. All right, let's try another one. Let's do this sum. Take the sum. And this time, let's not start with the first term. I'm going to use J. Let's start with the third term. Okay. Let's start from the third term and go all the way up to the fifth term. That's even better because that's fewer terms. Okay. And, okay. So again, so this means we start from the third term and we go all the way up to the fifth term and we add them up. So we're only adding up the third term, fourth term, fifth term. Okay. All right. Your function is going to be this. Okay. All right. So we need to find the third term. So to find the third term, we plug in 3 into this function. So 1 over 3. To find the fourth term, I'm going to plug 4 in right here. So I get 1 over 4. And the fifth term, that's when I stop. So the fifth term, I'm going to plug in 5 right there. I get 1 over 5. And these are the only terms I need to add. The third term, the fourth term, the fifth term. Third term, fourth term, fifth term. Add these all up and we get 47 over 60. Okay. Let's try this one. Letter C. Find the sum. And let's start with the fifth term. Okay. So I equals 5. And let's go all the way up to the 10th term. Okay. So that's still 6 terms. Okay. So that's 6 terms. And let's suppose that the formula is just I. Okay. Well, here, hold on a second. I want to make my eyes look the same so you don't think these are 2 different eyes. Okay. So here's I. This is your formula. It's just I. Okay. So it's kind of simple. So you're going to plug in 5. Well, when you plug in 5, you just get 5. When you plug in 6, you just get 6. Okay. And when you plug in 7, you get 7. When you plug in 8, you get 8. When you plug in 9, you get 9. And when you plug in 10, you get 10. Okay. And when you add these all together, you get 45. Okay. Let's try one more. Let's do the sum. Find the sum, starting with the first term. Going all the way up to the 6th term. Okay. That's supposed to be an I. There we go. Okay. So the first term all the way up to the 6th term. Okay. And this is your formula. A 2. Okay. Strange, huh? A 2. Like, where do you plug in the I, right? Okay, so there is no I to plug into. Okay. Which means that your first term is 2, your second term is 2, your third term is 2, your fourth term is 2, your fifth term is 2, your sixth term is 2. This means that every single term is 2. Okay. So first term, second term, third term, fourth term, fifth term, sixth term. Okay. And that one's easy to add up. It's 12. Okay. And that is pretty much it. I'm just going to give you some properties here to be aware of so that if you're asked to do the sum of two different functions or the difference of two functions, you don't freak out. Okay, so here are just some properties. And there are 3 of them, and then that'll be the end of the lecture. Okay, property of sums. Okay, so first one. Okay, so if you are taking the sum of, let's go k equals 1 to n. Okay, so if you're taking the sum of one function plus another one, right? So if you see something like this, so you have one formula there, and you have another formula there, 2 functions, right? Then what you can do here is you can actually separate them, okay? So, so you can do this one first, right? Get your answer, and then do this one second, get your answer, and add those 2 answers up, okay? And the same is true for subtraction. Okay, you can do the first one, get the sum of just the first function, get the sum of the second function. Oops, did I write plus? I did. Okay, take that off. Be gone. Now. Okay, hold on. It's not erasing. There it goes. Okay. So you can do the sums separately. That's basically what it's saying. And this one's kind of nice. I like this one. Of the 3, this one's probably my favorite. This one's a nice one to know. Okay. So if you're taking the summation and you have a constant here times your function. Okay. So if you have that, this is saying that, oh, you know what? You can factor out that constant. Okay. You can factor it out here and multiply it once you get the sum. Okay. Once you get the sum, then you can go ahead and multiply your answer by C. Okay. So that's all that's saying. But that one's, I kind of like that one. That way you don't have to end up with all these big numbers for each term. Okay. All right, so that is it. That is 12.1, which is probably the longest one of them all, except for the last section. The last section is going to be something entirely new. Okay, if you have any questions, email me or message me. We are almost done with the year, not the year, the semester. Okay, have a good night.